Okay, welcome everybody. Today we want to present our completely revised software. It is more than simply an update. We are facing a new paradigm in software development and customer relationship. The very special last months gave us the chance to finish many developments and achieve a new type of measuring devices. Let's try to explain it. A big and loud production machine produces a lot of pressure and internal sound waves. A metal machining process creates high-frequency, structure-borne sound. Analyzing this type of sound is a QASS expertise from the very beginning. We try to understand what is going on inside of machines and materials. Every crack detection we are doing, every machine monitoring, every small or big machinery creates amazing and complex signals. We call it information. Information that we have to interpret, to understand. We were frontiers using high-speed spectral analysis in production environments. Now our data structures come close to what a human ear and brain cognition is processing. When looking at these spectral sound picture from an industrial process, we can guess how sophisticated our human acoustic system is constructed. We try to draft our measurement technology like our human brain. The idea was to have a universal measuring instrument that is extremely versatile, that is capable of learning, that is multifaceted, and that can deal with all the inputs from the environment. So we have sensors, ears, feelings, fingertips, eyes, etc. Similar sensors are found in the industrial environment, in the machine environment everywhere. Sensors that provide information, and then we always reach the exciting point. What do you do with this sensory information? How to evaluate? How to get the meaning? Sampling sound is not enough. Sound is the movement of air molecules, billions of them, but without intelligent analysis, this is completely senseless and seems completely pointless. So we need something behind it that gives meaning to all the multiple sensory inputs. And in our case, that is our brain. It is an unbelievable miracle that this works at all and how easily we find our way around in our environment. Extremely demanding even for the most intelligent machines. Digitalization builds up a certain pressure and also a certain demand on our measurement technology. We do not particularly experience this pressure. QASS is a naturally friend of digitalization. Other industries feel this pressure much more strongly. The innovation shift in the automotive and manufacturing industry, electromobility, autonomous driving, massive use of sensors will generate growing demands for our technologies. No traditional car company is represented on this page. We see American pioneers. At the top is Google with autonomous driving, and they are certainly way ahead. So is Tesla as pioneer in electric mobility and autonomous driving, while the traditional car companies are actually now forced to follow. We are quite happy that the German automotive manufacturers are trying to speed up. Other industries also have to change their focus, driven by digitalization, equipping their machines with many sensors. The video is from a DMG Mori machine, one of the well-known German mechanical engineering manufacturers. And mechanical engineering is perhaps the second sector after automotive that has to speed up in digitalization. 3D printing technology, the topic, is being addressed in more and more traditional companies. We are in the project together with DMG Mori and are working on the sensory analysis of this 3D printing processes. We discuss how the mechanical engineering in Europe will move away from its "we process steel and we have controls and motor systems" towards intelligent analysis and sensor technology. So digitalization is a huge issue. Some demand a higher pace, but digitalization and Industry 4.0 are a growing wave. Water on our mills. Autonomous machines need intelligent sensing systems. We have built visualization tools into the software. This is perhaps a little bit beyond what is done in most sensor systems. So we can always understand which data we see and adjust the measuring parameters optimally to the machine. Also, the human-machine interface was always very important to us. For a completely autonomous system, you can perhaps leave that out, but in the phase up to that point, it's absolutely necessary. One of our base technologies is pattern recognition. We are working on it for years. It gives our software the ability to recognize information structures, and after learning it, to recognize it again and again. Like humans, who can recognize every word that we've learned once. We then grafted a system of operators onto this pattern recognition, a graphical programming method. Why? We suddenly had a lot of pattern signals. And then you ask yourself, how do I process all these pattern signals? It's not enough to understand individual words. We need to combine them meaningfully afterwards, which means I need the grammar to understand the context. Then we can read sentences, stories, maybe books. So we are developing the method to work with the learned patterns. And then we want our system to be able to learn these patterns fully automatically. There are thousands of different patterns in each machine. There are millions of different patterns and structures out there. We could, of course, teach it all in. Guess what'll work? Our teams are discussing how we can teach our measuring device to deal with these patterns. We now implemented types of signal clustering. That means we are trying to make sense of the patterns in a fully automated way, trying to figure out structures of emissions and sounds like different words and terms. And then we recognize them very quickly and store it in a library in the system, making our systems to work and learn faster and more automatically. Humans are always part of the picture. Our devices need the human advice, the already existing know-how. The devices need to know whether a measured part is really damaged or not. Was this significant pattern a crack or just machine noise? Judging the quality is complex and needs a lot of external information and intelligence. Our systems require human input. We call it human confirmation, to learn in the right way. Okay, what we did. We scanned signals very quickly, did spectral analysis. We filtered the data, we recognized patterns, we collect and classify patterns. We can somehow use operators to process the patterns together very quickly and analyze processes. With higher abilities, new demands are rising. Because we naturally say, okay, we can do a lot now, customers respond, then just do it. But this process was time consuming. We looked at the data, we analyzed the patterns, we clustered, we put a network of operators on top of it, and so on, everything elaborate. Not necessarily the speed you need. That is why we have added another accelerator in the last few months. We put in a scripting system. We used, trained and improved it in a number of workshops we held in the last months. To us it is still astonishing. We developed one application prototype within 1 week. We held 4 workshops, we developed 4 applications. We took our QASS software and hardware construction kit and built one new application within 1 week. Maybe somebody has heard JavaScript before. It automates and accelerates websites. Python is also famous as the language of machine learning and artificial intelligence. There are reasons why these languages are so popular and on the move. Scripting is modern and effective. We traditionally, if you can use this term for a 20-year young company like QASS, we traditionally develop engineering-wise with C++, a well-known, robust, standard programming language. I will try to explain the difference to modern scripting language using an analogy. Our basic method, our C++ programming, robust and well proven. It is a bit like designing and building machines. A motorcycle, for example. You need a longer construction phase. You implement this very carefully, very robust. In the end it works, can be produced, built and delivered perfectly. So this is how you build a motorcycle. But the real fun comes afterwards. And that is where our scripting comes in. It is about using base abilities in a very flexible and maybe even playful way. It uses all the technical features of the motorbike and then plans the tour and drives to the lakeshore on Sundays. We call it scripting. We use it to write a new application in no time at all. We use it to build applications we were not able to before. These first 4 applications are already published on our website. In our workshops we deepened and tested the new method. Many QASS colleagues who have had nothing to do with programming before suddenly used scripting. Fortunately, it is easier to learn than C++, so we navigated quickly and easily through the data and built new applications. Here in the bottom left corner we have the application for bending straightening. Of course, one could say, what a nonsense. We have had it for a long time. We have been selling crack detection very successfully for many years as market leader. But the market request was clear. Can you please make the user interface easier? What QASS delivered became more and more complicated. We thought, understood, but there's no way around. We have to recognize patterns, we have to cluster data. You have to learn how. Now we built a simplified interface in a short time, which we couldn't in years with the old methods. The GUI worked after 1 week. The presented application was drafted in 2 weeks. But of course our straightening team had additional ideas, creates additional plugins. We took existing solutions in the field of joining and force fitting and crafted 3 different applications for assembly processes. One type will be presented today. Scripting is great for all the different types of assembling. Each process looks differently. Doesn't matter, we script the measuring logic, we combine several sensor types, we derive the best decision about the parts and machine's quality. We created a brand new solution for plastic injection molding. The structure-borne acoustics transmits the information about tool behavior from the inside, in process. Using scripting logic, the team developed new algorithms to unveil the tool information. So we are introducing a brand new solution to the market. Last but not least, we applied the scripting to our micromagnetic field of applications. And the process of application development is ongoing. Let's have a look at our PenGUI. The name sounds a bit like penguin, and we had the Linux mascot in mind when we chose that name. PenGUI, programmable, extensible, graphical user interface, driven by the scripting engines which already extend our measuring features. Here at the front we can apply all kinds of animations to make the measuring process understandable. Pictures, charts, listings, actuators. Everything is editable and can be used to present even complex data analysis in the simplest way. Machine operators will recognize their manufacturing process in the QASS analysis procedure. In fact, we have created 2 interactive and customizable levels to which the user can contribute his ideas. The first one refers to scripting. Through scripting, the user can adapt measurement analysis as he likes, so the user will be able to access the basic functions of the measurement system, its framework, which we programmed in C++. We have made the system even more intelligent and practical regarding measurement analysis. And the second level refers to the graphical user interface. Also here the user can contribute his ideas, and at the same time he can access the functions that he has previously programmed. This means that access to complex data analysis becomes easier. Okay, so we actually have a new approach. In fact, a paradigm shift. Where in the past, when we took on new projects, we needed a relatively long development time to really get an application ready, we would now work completely differently. It is the change of development speed, the ability to combine several types of sensors, the ability to script new algorithms, the ability to access the Python libraries and to show all results in a customized user interface. This all leads to completely different kind of work at QASS. We now collect the relevant information about a client's process. If all goals are defined and seem to be achievable, we set the milestones with our clients. We then collect data in the client's manufacturing process. 2 weeks later, we start the application development. Within 10 working days, the analysis logic and the user interface are finished, and we evaluate the customized system in the target process. We develop new solutions up to 50 times faster. We finish our projects 10 times faster. Our new approach enables us to finish new projects within 8 weeks of QASS working time. Well-known manufacturing processes will take only hours or days of customizing. We will derive and offer a number of standardized applications from our newly developed apps. I think the first topic that is presented is joining and force fitting. Well, we had 4 workshops. We built 4 new applications, and colleagues from the teams from the workshops will now present and introduce it in detail.